On the 11th of March 2011, Japan was shaken by an accident known as the Great East Japan Tohoku Earthquake, also known as Higashi Nihon Daishinsai in the Tohoku region. An undersea megathrust earthquake occurred east of the Yoshika Peninsula. It lasted approximately 6 minutes and caused a tsunami after that. The earthquake's magnitude was 9.0, the most powerful earthquake ever recorded in Japan. It triggered huge tsunami waves that reached heights of up to 40 meters. The tsunami hit the east coast of Japan and swept away entire towns, residential areas, and fishing ports. It also severely damaged and destroyed industrial and commercial zones. Both natural disasters resulted in the deaths of approximately 20,000 people, or were declared missing and initiated the nuclear disaster at the Fukushima Daiichi nuclear power plant, with approximately 150,000 people receiving evacuation orders. This disaster significantly impacted the Fukushima Daiichi nuclear power plant, leading to severe damage to the reactors and the release of radioactive materials into the environment.
Fukushima Daiichi is 250 kilometers northeast of Tokyo. The nuclear power plant has 6 reactors, each reactor successively commissioned during the 1970s. Units 1, 2, and 3 were operating at full power. The core in Unit 4 was unloaded. Units 5 and 6 were in cold shutdown. When the earthquake hit the coast, seismic sensors triggered the insertion of control rods. Although fission reactions stopped, the residual heat had to be removed. The off-site power supply was lost, and the emergency diesel generators took over automatically. They supply electricity to the backup systems needed for core cooling. The tsunami wave arrived less than an hour after the earthquake. The waves went over the seawall, flooding the lower parts of buildings and disabled the emergency diesel generators. On Reactor 1, the operator was unable to reactivate the heat exchanger. The core was no longer cooled. It would be the first to melt. On Units 2 and 3, the batteries were still operational. They operated some of the valves. The turbine-driven pumps ran for nearly 24 hours and then stopped. The cores were no longer cooled. The meltdown scenario is almost the same in all 3 reactors, only the dates changed. The water in the reactor vessel evaporated. The fuel became uncovered. Heated up to a temperature of 2,300 degrees Celsius, the fuel melted and mixed with the materials from the structure to form a magma called corium. The corium flowed down to the bottom of the reactor vessel. According to Japanese officials, it pierced the reactor vessel before falling on the concrete basemat inside the containment. Hydrogen reacts violently with oxygen in the air. The explosion blew apart the frame at the top of the building, apparently without damaging the containment building. Radioactive elements not yet trapped in the wet well suppression pool were released into the environment. Due to the absence of usable fresh water on the site, the operators decided to inject seawater into the reactor vessel. This solution, far from ideal, since salt is chemically active, had at least the advantage of cooling and stabilizing the corium. In the 4 days following the tsunami, the 4 reactors were damaged by explosions, and 3 of them with core melt. Although it has kept its structure intact, Reactor 2 is the current source of the most important radioactive releases into the soil as well as into the sea. The explosion took place inside the building. Operators have probably encountered difficulties depressurizing the containment, and the wet well suppression pool broke. This loss of leak tightness led to the discharge into the atmosphere of unfiltered radioactive elements and to the spreading of highly contaminated water in the buildings, leading to highly polluting discharges into the sea. The explosion of Reactor 4 was due to hydrogen, even though the core was completely unloaded. The hydrogen came from Reactor 3 via a joint pipe. Gradually, the situation began to stabilize. By the end of March 2011, fresh water had replaced seawater. In July, the reactor cooling system was again in operation in closed circuit, thereby avoiding discharges of contaminated water into the environment. In December 2011, Japanese authorities officially declared that the nuclear power plant reached the cold shutdown state, an expression used when the cooling water does not evaporate anymore and remains liquid below 100 degrees Celsius.
The Fukushima nuclear disaster of March 11, 2011, and what actions did Japan take in its aftermath? This was one of the most catastrophic nuclear accidents in history. The primary entity held accountable for the disaster was the Tokyo Electric Power Company, or TEPCO. Investigations revealed that TEPCO failed to prepare the Fukushima Daiichi power plant for natural disasters of this magnitude. Despite warnings from experts about the region's vulnerability to earthquakes and tsunamis, TEPCO did not implement sufficient safety upgrades, such as higher seawalls or improved cooling systems. The Japanese government was also criticized for inadequate regulatory oversight and a slow response during the crisis. Many argued that weak safety standards and lenient policies toward nuclear operators contributed to the scale of the disaster. After the disaster, Japan took significant steps to address the crisis and its aftermath. These actions included 1. Evacuation and safety measures. Over 150,000 residents were evacuated from areas around the plant to protect them from radiation exposure. 2. Decommissioning the plant. TEPCO began the long and complex process of decommissioning the reactors, which is expected to take decades. 3. Decontamination efforts. Massive efforts were launched to decontaminate affected areas, including soil removal and water treatment. Japan also implemented major policy changes. 1. Revised safety standards. The government restructured its nuclear regulatory authority to enforce stricter safety guidelines. 2. Renewable energy investment. The disaster prompted a shift in Japan's energy policy, with increased focus on renewable energy sources like solar and wind power. 3. Global collaboration. Japan sought international expertise to manage the crisis, improve safety protocols, and share lessons learned to prevent future incidents.
Japan signed the Convention on the Physical Protection of Nuclear Material Amendment Conference on July 8, 2005. This convention provides a framework that binds and obliging contracting parties to apply protection measures not only to the international transport of nuclear material, but also to the use, storage, and transport of nuclear material within a country, as well as to criminalize the act of sabotage. This convention was renewed at the second informal open-ended expert meeting because participants recommended to the IAEA Secretariat that fundamental principles for physical protection of nuclear material be drawn up based on INFCIRT/225/Rev 4. After the incident happened, Japan applied the convention on early notification of a nuclear accident. Japan ensures countries notify the IAEA and neighboring states about nuclear incidents as soon as possible because of the potential transboundary effects. Several countries and organizations also provided assistance to Japan under the framework of the Convention on Assistance in the case of a nuclear accident or radiological emergency. This convention facilitates international collaboration in response to nuclear or radiological emergencies. Among the countries that helped Japan were the United States, France, United Kingdom, South Korea, and some more countries. Even the international organizations, World Health Organization, that assisted with health monitoring and public communication regarding radiation risks, and also World Food Program, WFP, supported logistics for food distribution in affected areas.
The Fukushima Daiichi nuclear disaster incident also got concerned by the World Health Organizations. WHO conducted assessments of health impacts related to radiation exposures and provided guidelines for managing public health risks with the disaster. The International Atomic Energy Agency, IAEA, increased safety standards and regulatory framework after the disaster happened. They aim to strengthen the global nuclear safety framework. This plan included comprehensive assessments of nuclear safety framework practices worldwide and emphasized the need for improved emergency preparedness and response capabilities. This framework must followed by certain European countries and others, include Germany, France, China, and United States of America. In Japan, the Fukushima incident led to a dramatic shift in energy policy. The government undertook a comprehensive review of its nuclear energy strategy, resulting in a temporary shutdown of all reactors while new safety regulations were developed. The long-term implications include a significant reduction in Japan's reliance on nuclear power with increased investments in renewable energy sources like solar and wave energy.
Secondly, impact on the environmental aspect. Nuclear power plant space is located on the seaside near the Pacific Ocean for easy access to seawater for cooling systems purposes, and also nearby the towns of Okuma and Futaba. However, after the incident meltdown and leaks of nuclear, it happens to flow into the ocean. This liquid contained radioactive isotopes, cesium-137, contaminated the Pacific Ocean, affecting marine life and the food chain. Affecting local sea activities, and some species show persistent contamination due to bioaccumulation. Direct discharge harmed the marine ecosystems, including exotic species, according to the Convention on International Trade in Endangered Species of Wild Fauna and Flora, CITES. In 2023, the Japanese government planned to release treated water containing tritium into the ocean, sparking concerns about environmental and public health, even though the IAEA ensures that the water is safe. Japan received opposition from local fishermen, environmental groups, and neighboring countries like China and South Korea, provokes controversy and criticism by the international community regarding water irrigation to neighboring countries questioning Basel Convention in 1989.